In this video, we're going to talk about increasing and decreasing functions. For a continuous and differentiable function f, the function values, in other words the y values, are increasing for all x values where f prime x is greater than 0, and the function values, the y values, are decreasing for all x values where f prime x is less than 0. In other words, when the first derivative is positive, the function is increasing, going up as you read from left to right. And when the first derivative is negative, the function values are decreasing, going down as you read from left to right. In our first example, we'll determine the intervals of increase and decrease for the function y equals 3x cubed plus 3x squared minus 2. Well, first thing we do is determine our first derivative, which is 3x squared plus 6x. Now what we do is we set that first derivative equal to 0, we factor the 3x, and we determine that the first derivative equals 0 when x is 0 or x is negative 2. That allows us to set up intervals to do interval testing. So I'm going to do interval testing where I'm going to set my intervals up at x equals negative 2 and x equals 0, and draw a number line. And what I'm testing is the first derivative, and so the first derivative is equal to 3x times x plus 2. Well, when x is a number less than negative 2, this first factor is negative and the second factor is negative, making the product positive. When x is a number in between negative 2 and 0, this factor is negative, this factor here is positive. And that makes the overall product of those two factors negative. And finally, when x is greater than 0, both factors are positive, making the product positive. So to the left of negative 2 or to the right of 0, the first derivative is positive. In between negative 2 and 0, the first derivative is negative. So we can say that the intervals of increase are when x is less than negative 2 or x is greater than 0. We put that in set notation form. And the interval of decrease is right in between when x is in between negative 2 and 0. We put that in set notation form. For our next question, we'll determine the intervals of increase and decrease of the function f of x equals x over x squared plus 1. Well, to determine the derivative here, we're going to use the quotient rule. So we're going to say the denominator times derivative of the numerator minus the numerator times derivative of the denominator over the denominator squared. So we have x squared plus 1 minus 2x squared all over x squared plus 1 quantity squared. That simplifies to 1 minus x squared over x squared plus 1 quantity squared. And 1 minus x squared factors to 1 minus x times 1 plus x. And then that's all over x squared plus 1 quantity squared. Well, we want to determine where this first derivative is equal to 0. If I set the first factor equal to 0 and the second factor equal to 0 independently, I get the values of x equals 1 or negative 1. So now what I do is I make a interval testing number line using f prime of x, which is given by this expression right here. I see that when x is less than negative 1, 1 minus x is positive, 1 plus x is negative, making the numerator negative. The denominator is always positive. So I have a negative first derivative when x is less than negative 1. In between negative 1 and 1, I have the factor 1 minus x is positive, and the factor 1 plus x is positive. So I have a positive numerator over a positive denominator, making the first derivative positive. And finally, when x is a number greater than 1, 1 minus x is negative, 1 plus x is positive. My numerator is positive, my denominator is negative, so the first derivative is negative. So I can say that the intervals of decrease are when x is less than negative 1 or x is greater than 1. I put that in set notation form. Or if I wanted, I could put it in interval notation form. In other words, the intervals of decrease are from negative infinity to negative 1 or from 1 to infinity. Moving on, using the same number line, I can see that when my interval of increase is when x is in between negative 1 and positive 1. So in set notation form, my interval of increase is negative 1 to 1, or in interval notation form, I can write it the same way. Now in this next question, we're given a graph of y equals f prime of x and asked to graph the curve y equals f of x. Now, we're used to seeing questions where we're given the curve y equals f of x. This is a little bit different. This is telling us that in this curve, every y value you see is actually the derivative of the function f of x. So what they're saying is, suppose right here, suppose this is an x value of -1 and suppose this is an x value of +3. What they're telling us is that at an x value of -1 or an x value of +3, this y value, which is the first derivative, is equal to 0. So what that tells me is at an x value of -1 or an x value of +3, the first derivative equals 0. So I have to keep my eye out. I might have a maximum or minimum point there. So this is a x value of -1 right here, and this is an x value of +3 right here. Now, I see that to the left of an x value of -1, all these y values are positive. Well, if these y values are positive and they represent the first derivative, they're telling me that the first derivative has positive values for all the numbers to the left of -1. I'll repeat that. This x value is -1, and so what we're saying is that to the left of -1, all of these y values are positive, but those y values represent the first derivative of f of x, so our curve that we're trying to graph, which is f of x, will have a positive first derivative. So what I'm going to do is I'm going to draw a positive first derivative, and then I'm going to draw a 0 first derivative. Now, in between this -1 and 3 value, I have negative y values. Well, the y values are the first derivative, so I have to draw a curve that has negative first derivative values in between x of -1 and x of 3. So maybe I draw something that looks like this. That gets me to this point here. This point here represents a y value of 0, but that y value is the first derivative. So if I'm going to graph the actual curve, what I'm going to do is I'm going to draw a curve that has a first derivative equal to 0 at that point. Then from here on over to the right of this number, that first derivative will be positive because these y values are positive, meaning my the slope of my curve will be positive, and it'll look like this. So now if you look at that, it kind of makes sense. The red curve is y equals f of x, and the black curve is y equals f prime of x. Well, if I look at that black curve, I would say that looks like a degree 2 curve. It's a parabola, it's a quadratic. If I look at this red curve, I would say that looks like a degree 3 curve. And doesn't it make sense that if we start with a degree 3 curve, that the first derivative would be a degree 2 curve using the power rule? That actually makes sense to me. For our last question here, we're going to find the constants a, b, and c such that the graph of y equals -x cubed plus ax squared plus bx plus c decreases to the point -6, -200, then increases to the point 256, and then decreases thereafter. Okay, well, since we know that the curve is a smooth polynomial curve, a curve that looks like this is a smooth polynomial curve, it's a cubic. And since we know it decreases to x equals -6 and increases after x equals -6, we know that y prime equals 0 at x equals -6. Well, y prime is equal to -3x squared plus 2ax plus b. Again, all we're doing there is we're just determining the derivative here. -3x squared plus 2ax plus b. Okay, so we can say that the first derivative equals 0 when x is -6. So we plug in an x value of -6. And we can say negative 3 times negative 6 quantity squared plus 2a times negative 6 plus b. Meaning 0 is negative 108 minus 12a plus b, which means b is equal to 12a plus 108. So we're going to keep in mind equation number 1. Now similarly, same logic, the curve's a smooth polynomial curve that increases to x equals 2 and decreases after x equals 2. That means y prime equals 0 at x equals 2. Well, again, y prime is this expression, so I just let y prime be 0 and I let x equal 2. So 0 is negative 12 plus 4a plus b, which means b is going to be positive 12 minus 4a. And so we've got equation 1 and equation 2. Now, if you notice in equation 1 and equation 2, they're both expressions for b. So what we can do is make them equal to each other. So putting together 1 and 2, we can say that 12a plus 108 equals 12 minus 4a. And then solving that gives us a equals negative 6. Well, since b is equal to 12 minus 4a, I could have used 12a plus 108, but since b is equal to 12 minus 4a, and a is negative 6, I can solve for b. b must be equal to 36. So now we have a equaling negative 6 and b equals 36, and so we can rewrite the expression this way. Y equals negative x cubed minus 6x squared plus 36x plus c. So now what we want to do is solve for c. Now, we know the points negative 6, negative 200, and 256 are both on the curve, so we just choose either one of those points. And in this case, we'll choose 256. I'm going to let the y value be 56, and I'm going to let the x value be 2. And doing that gives us 56 equals negative 8 minus 24 plus 72 plus c, meaning c is equal to 16. So we have our a value, we have our b value, and we have our c value, and so we can write out our therefore statement in red.